Today what we're going to be doing is simplifying complex fractions. Now the method that we're going to do that is called the LCD method, or least common denominator method. So the first thing we need to do is identify the least common denominator of all the little denominators, and I'll refer to those when we look at some examples here. Now we're going to multiply both the big numerator and big denominator by that LCD of the little denominators. Okay. We will eliminate all little denominators when we do that. And afterwards, we'll simplify the remaining terms in the numerator and denominator. And if we can factor it, we want to factor and simplify. So example 1, what we have here is we have a complex fraction where this is our big fraction line, and in that numerator of the big fraction we have 3 over 2 minus 1 over 5. So these are the little fractions, 3 over 2 and 1 over 5. Then in the denominator we have 5 over 6 minus 2 over 3. Those are little fractions. So what we need to do is we need to find the least common denominator of 2, 5, 6, and 30. Those are all the little denominators. So one way to do that is to multiply those numbers out, 2, 5, 6, and 3. That will not always give you the smallest common denominator or least common denominator, but it will give you a common denominator. So if you're stuck, you can just always do that. So if I do 2 times 5, that's 10, times 6, that's 60, times 3, that's 120. So that's a pretty big number, but I'm wondering if there's a smaller number, the least common denominator, that share all of these. Well, if you think about the number 30, you can do 30 divided by 2, 30 divided by 5, 30 divided by 6, and 30 divided by 3. So a smaller common denominator, least common denominator, would be 30. So what we're going to do is we're going to multiply by 30 over 30. And actually, I'm going to write this over here. Now, when we do that, we're going to distribute 30 to all the numerators, all the little numerators, okay? So multiply both the big numerator and big denominator by the LCD. And what's going to happen is things are going to simplify. So 30 times 3 is 90, so we have 90 over 2, minus 1 times 30 is 30 over 5, divided by 5 times 30 is 150, and then 2 times 30 is 60. So now what's going to happen is all of these smaller fractions can be simplified. 90 divided by 2 is 45. 30 divided by 5 is 6. 150 divided by 6 gives you 25. And 60 divided by 3 is 20. So now we can do 45 minus 6, which is 39. 25 divided by 5 is 5. And then we always want to check, can we reduce this fraction, 39 over 5? We can't reduce 39 over 5, so that means this is our final answer. So this process looks pretty messy because we're multiplying a lot of things by that 30. But the reason we do that is because then all these small fractions can then be reduced. And once we reduce all the smaller fractions, then it becomes a simple subtraction or addition problem, and then we have to see if we can reduce the fraction at the very end. Now you may notice in letter B that instead of numbers we have algebraic expressions, or x's, in the denominator. So the LCD here is not going to be x minus 5. You may be thinking, well, this one has an x, this one has an x minus 5, this one has an x, so I just need to do minus 5 there. We can't just add stuff to a denominator to make them common. We have to multiply. So the LCD for this problem is actually x times x minus 5. So we're going to multiply each small fraction by this. So now this whole thing is getting distributed to each of the numerators. So again, this is going to look a little bit messy. So we're going to have 6x times x minus 5 over x minus 5 plus 1 times anything is just going to be what we started with, or what we're multiplying by. Okay. So then in the denominator, 3x times x minus 5 over x minus 2x times x minus 5 over x minus 5. Now, the reason we do this is now we can cancel things out. We have an x minus 5 factor in the numerator. We can cross it out with the x minus 5 in the denominator. In the second little fraction, we have x over x. Those cancel. Then we go to the bottom of the big fraction. We have x and x that cancel. And then in the last one, we have x minus 5 and x minus 5 that cancel. So notice how all the little denominators are now gone. So this is going to leave us with 6x plus x minus 5 over, we have 3 times x minus 5 minus 2x. Now we have to simplify this. 6x plus x is 7x, so we have 7x minus 5 over 3x minus 15 minus 2x, because we're distributing the 3 here. So we have 7x minus 5 over 3x minus 2x is x minus 15. So again, it looks very messy up in here, but as soon as we start canceling things off, it becomes much more manageable. All right, now with this one, the first step that I want to do is to factor anything that we can. So the numerator is x squared minus x minus 6, so that's going to factor to x minus 3 times x plus 2 over, I can factor out an x, we have x times x plus 4. That's all over x plus 2, x plus 2 over x. So the LCD for this one, we look again at the little denominators. We're going to multiply everything by x times x plus 4. And multiply x times x plus 4 over x times x plus 4. And I'm not going to distribute anything just yet. I'm just going to leave it all in factored form. So my numerator of the numerator of my smaller fraction in the top right here is going to be the x minus 3 times x plus 2 that we factored times x plus 4 all over x times x plus 4. Okay, that's this part right here. Divided by x plus 2 times x plus 4 all over x. Then we could start canceling. In purple, we have the x and x that can cancel, and x plus 4 and x plus 4 cancel. In the denominator, or in red, x and x cancel. So now this is going to equal x minus 3 times x plus 2 over x plus 2 times x plus 4. Now we have an x plus 2 factor on top and bottom. Those cancel. So this is actually going to be equal to x minus 3 over x plus 4 as our final answer. All right, now letter D goes back to talking about some of the negative exponent rules that we learned a while ago. So first thing I'm going to do is I'm going to rewrite this using positive exponents. So k to the negative second power is really 1 over k squared. Then we have 2 over k to the first power minus 1 over k squared. So our least common denominator for this problem, our LCD, is going to be k squared. And the reason why it's k squared is I have k right here and I have k squared right there. So in order to add those or subtract those, each denominator would have to be a k squared. So we multiply the top and bottom by k squared, and this is going to get distributed to all the fractions. So this is going to be 4k squared minus k squared over k squared divided by 2k squared over k minus k squared over k squared. Now, there's no fraction with this 4k squared, so it's going to be 4k squared minus k squared divided by k squared is 1, over, we have 2k squared over k, well, the k in the denominator and one of the k's from the k squared will cancel, so it's going to be 2k, and then again, k squared over k squared is 1. Now, the numerator can be factored as a difference of two squares, because we have 4, which is a perfect square, we have k squared, which is a perfect square, and then we minus 1, which is a perfect square. Then we 2k, going to factor 2k plus 1 and 2k minus 1 over 2k minus 1. Now the 2k minus 1 factors can cancel, so then we are left with 2k plus 1 as our final answer. All right, on the next page, normally I would have you try some of these, but I know this is a confusing topic, so I'm going to walk through them. Anyway. And if you want to test yourself, you can pause the video and try it. But again, I know this is a difficult topic, so I'm going to try. I'm just going to walk you through these problems. So again, we're going to be looking at these denominators here, 10, 5, 2, and 4. We want the least common denominator for all of those. Now, you could say, you could multiply all those, but you're going to get a pretty big number if you do that. So we want the smallest number I can divide all these by. You're going to be thinking 80. 80 can be divided by all of these numbers, but we want to see if there's anything smaller. 40 also works, but we can actually divide all of these numbers by 20. And again, if you use a bigger number, that's okay. It's just going to mean you're going to have to reduce at the very end. But if you multiply, or if you divide all of these into 20, 20 divided by 10 is 2, 20 divided by 5 is 4, 20 divided by 4 is 5, and 20 divided by 2 is 10. So I'm going to multiply the top and bottom by 20. And then distribute it to all the numerators. So we get 20x over 10 minus 20x over 5 over 20x over 2 minus 60 over 4. And then we can simplify. 20 divided by 10 is 2, so we have 2x minus 20 divided by 5 is 4, so 4x, all over 20x divided by 2 is 10x, and then minus 60 divided by 4 is 15. Now we can combine like terms in the numerator. 2x minus 4x is negative 2x, all over 10x, whoops, minus 15. So this will be your simplified answer. Now, for this one, this is kind of like what we did up here, but instead of x minus 5, it's x plus 4. So the LCD here is going to be x times x plus 4. So multiply all of these by x times x plus 4, and then we're going to distribute that to each numerator. So we're going to have 5x times x plus 4 over x plus 4 over 1 times anything is going to be just what we're multiplying by. And then 2x times x plus 4 over x. Now we can cancel x plus 4's, x plus 4's, x and x. So we are going to be left with 5x over, we're going to have x plus 2 times x plus 4. That we can distribute that 2. When we distribute that 2, we get 2x plus 8. So our final answer is going to be 5x over 3x plus 8. Okay. So again, I know this is a confusing topic. It looks very messy. That's why we really need to make sure we're writing out all of our steps and then canceling things off when we can. So that's it for this video. Make sure to, thanks for watching. Make sure to like it and subscribe.